Welcome everyone. So this is week 4. This week we have MSS and UQCS collab. Polymathian is a sponsor of both of us, and we have Mitchell Grice coming to talk to us today. So he's going to talk about some of the processes they have behind Polymathian, but specifically on something cool they just have on the side, and that they automate their team lunches. I don't actually know too much about it, but I do want to hear more, so I'm going to hand over to Mitchell. Yeah, thanks.
Thank you. A quick sort of why should you bother listening to me. So I work at Polymathian, like I said, we're a sponsor of both the clubs here tonight. I've been there for about 7 years, and I started out as a casual software developer while I was studying here at UQ. I did software engineering and business management, and I also spent 4 years in UQCS, did 2 years on the committee, so this is definitely an interesting day coming back and seeing everything. So what we do at Polymathian, I'll get into this more at the end, but just to sort of set up the kind of company. We produce computer software using industrial mathematics, decision science, operations research, simulation, and that software is used by large corporations around Australia and around the world to help improve the decisions that they make. That. Today, I'm going to talk about something much more important than multi-million-dollar businesses, which is getting free food. I'm going to tell a bit of a story about Polymathian, about sort of the evolution of something a bit silly, but that if you break it down, it is a process like anything else, and that you can apply the same sort of process engineering fundamentals to. The story isn't really important, it's really more about that process engineering. So, back when the company was young, we would go out for Friday lunch. Every Friday, not sure I have my slides, but we would all go out for lunch together. We'd just go to a restaurant. There was like 8 people in the company, but inevitably, sort of as we got bigger, it was harder to just rock up to a restaurant at 12 o'clock and demand they feed us all, demand they seat us all. So that process and that something that was just happening ad hoc sort of naturally evolved. So we switched to a delivery approach. The upside of delivery being that it can be ordered hours in advance, and you can give the restaurant plenty of time to do that, and you also don't have to sit there while they're preparing the food. Usually a lowly casual, whoever was sort of at the bottom of the food chain, which at the time was me, would basically get told which restaurant to do. I'd open up Uber Eats on my phone and walk around and ask everyone what they wanted to eat. It wasn't very efficient, it wasn't very well thought out, but it was a bit of fun, and we were kind of small enough that no one really gave it any thought. But then sort of complications started to show up, as they do in pretty well any process. The dimensions that you're working in scale, and what you sort of initially decided to do in an ad hoc way doesn't continue to work as you get bigger or as your business changes or whatever it is you're doing changes. So the first complication is that people wanted to have input on what we wanted to have for lunch. As we got more and more people, just having some random person shout out a restaurant wasn't working. We ended up having sort of the directors of the business having a favorite restaurant, and we ate there every single week, whether you liked it or not. So we decided to add a voting system. So that's an extra step now that we have to deal with. And then the other problem was, if we are ordering delivery and I walk around the room, if you're not at your desk at the exact second I walk around, you miss out. If you're actually working hard and sort of talking to a customer or on a call, you're the one who ends up missing out, which sort of made people quite upset. So we needed some way to fix the walking around problem. We also needed to track standing orders, so you can sort of see this process organically growing and becoming more complicated. So let's just write down sort of what we have at this point. So there's some process where everyone in parallel votes for a restaurant. Some organizer, me, consolidates that information back together, picks a restaurant. Then that process fans back out again to everyone in the group, who then puts in their orders asynchronously, and then that needs to consolidate back down to a single person who puts the actual order in. Not looking too bad, but you can see that as the two fan-out parts grow, as we get more people, there's an obvious dimension there that's going to scale poorly as it currently works. So we tried to automate this. We made basically a Google form, a Microsoft form, and then every week we'd go into Slack and just ping at everybody and say, go fill in the form. And then someone would take the Excel that came out of this hand process and turn it all into some information, and then ping everyone again and tell them that they need to go and put their orders into a giant spreadsheet where we had all the restaurants across the top and the people down the side, and that also quickly became unmanageable, just wall of text. There was also an even earlier version of this that I have a screenshot of, where we did it entirely in Slack using emoji reactions, where you would vote on the restaurant using a big list of emoji, like a little sushi for the sushi place. And then you would pick which restaurant you wanted using more emojis, and then you would message someone your order, and it was just a disaster. But this worked. This worked for a while. You can see on the left, we've got a fair number of people that goes off the page. And across the top, I think we ended up with sort of a dozen or so restaurants, and it kept working. But inevitably, with any other process, more things kept happening. More people wanted to add more to the process, or the process reached sort of a tipping point where as it scaled in a certain dimension, the solutions kind of fell over. The ones that we hit were needing to introduce some sort of load balancing, as if we were talking about servers here, where one restaurant can't really, even with a few hours notice, may not have the kitchen size to cook for 20 people, 30 people. So we need to start splitting up people across multiple restaurants. So in addition to asking people to vote, they also need to pick which restaurant they want to order from. You could go for the sort of naive approach there, where you assume that the one people voted for as their highest preference is the one they want to eat at. But humans are humans, and on Thursday everyone would vote for salad, and then on Friday actually want a pizza. So that didn't really work out. Also, people would keep forgetting, they'd mess up the spreadsheet, they'd change the spreadsheet after the order went out. And it sucks as an experience, right? So this process is spread across multiple tools. It requires people to be trained in onboarding with multiple parts of a process, and it requires them to go to a process and come back from it. Again, it's Friday lunch. It's kind of trivial, it's a bit silly, but it's an example of how a process that you introduce sort of ad hoc can scale poorly and where it might need attention. So it became a bit of a time sink. Coordinating the lunch was kind of costing more time and money than the actual food was providing. People were getting less happy, mistakes were being made. It wasn't really serving the purpose. The process was trying to deliver something that it just was no longer delivering. And any process which is not essential to business function and isn't fulfilling that purpose anymore, it might be most improved by just getting rid of it, right? Doing something different. And that is inevitably what we did. And that became what was known as sort of the first dark age of Friday lunches. But we just replaced it with something else, something that scaled better, right? It's pretty hard to cook 20, 30 hot meals on demand. It's pretty easy to go to IGA and get 20 or 30 Tim Tams and some soft drinks or whatever, or it's easy to go to the pub and just line up and pull 30 beers. So we just started doing things like that instead. Some people missed it, but not really. Everyone was pretty happy with sort of free drinks and biscuits. But there was one person who I won't name who was very, very adamant it should make a comeback and campaigned quite hard for it. So we sort of sat down and put in some actual process engineering this time. So Friday lunch had gone because it became this unmaintainable process. But we are a company who specialize in producing computer software to improve processes, to optimize processes across multi-million-dollar supply chains. Why can't we get food delivered? So surely we should be able to make that work. And really the failing was that it grew organically without any sort of purpose and without any sort of thought. So the question was, if we applied the same sort of high quality engineering effort that we apply to our customers to something really small and silly, what would that actually look like? So we did that, and we decided to go through a sort of full system requirements analysis and figure out what we really needed. So we needed some sort of system to do what you can see there on the screen. It absolutely must handle the voting and ordering, and it must not require people to be trained on it, have to sign up for some new thing. If we found some like SaaS provider, I don't know, FridayLunch.io or something, probably couldn't do that because then everyone would need an account, they'd have to go to the website. We need it to be as simple as possible and to reduce that time sink. That was the real problem. Ideally, also people should be able to do it from their phone, and also, this is a bit of a fun example. This isn't some corporate supply chain where every sort of cent matters. It needs to be kind of fun. And I think that kind of went away when it became a spreadsheet, which is usually not a good sign of fun, though I think many engineers may disagree with me. So looking at what we had here in terms of requirements, we decided a chatbot was a pretty good solution. So chatbots have some pros and cons. The pros are that we can install into something we already have. We use Teams, but this would apply to Slack or Discord. Importantly, it can work each person through that process individually. So instead of being a pull kind of situation where you tell everyone to go do something, the process comes to you. And that's something we usually don't get an opportunity to do. Usually it's pretty hard to build tools that go to people. But in this particular case, it worked out quite well. It can also proactively start talking to people when the stages happen. So that sort of push experience continues. In the process we saw before, it had that fan out and fan back in. In that particular case, each of those times it fans out, we need to go back to every person and ask them a new question. They're also pretty easy to develop. I'm hoping UQCS bot still lives today in some sense on Discord, but also anyone who's contributed to that would find that it's a pretty easy thing to set up these sort of request-response conversations. The big con of chatbots is that they kind of have a bad reputation. I'm sure everyone's had an experience where you go to like a bank website or something and some little face pops up in the corner and insists that you talk to it like a human, but it's just absolutely as dumb as a bag of rocks. That kind of experience can really detract from the process, and we didn't want to end up back where we were. In this particular case, that frustration really stems from the interface pretending to be a person when really it's not. There are some cases where that's done incredibly well, but they are sort of few and far between. But in our case, really all we're doing is taking like a HTML form and just pushing it to people. It doesn't have to be smart. It just has to understand yes, no, and like the word grilled. It doesn't really need any sort of really like machine learning or artificial intelligence or understanding anything. The other downsides that were specific to us, Teams is a real pain in the ass to develop for, but if you've got Slack or Discord, it's substantially easier. And an interesting one that is somewhat unique to chatbots is that debugging them can be quite difficult when all of your people have completely isolated, independent experiences. So it's pretty hard if someone reports an issue to go and have that same issue, because it may depend on an entire conversation that you can't see. So we went through and decided to go with a chatbot, ended up designing some pretty simple chat flows. So every Thursday afternoon, it goes out and messages everyone in the company and asks them, do you want lunch tomorrow? Ask them if they want to vote, and if they do, ask them to put in that vote. And that's all a experience that comes to you, and I'll show you what that looks like later. And then on Friday morning, it comes to you again, asks you which of the winning restaurants you want to have food from, and then asks you what your order is. And there's some nice smarts there that we sort of baked in to be able to offer you what you had last time and see if you just want the same as last time. So more on the tech side, in terms of implementation, we went for a really keep it simple, almost to a detriment, where we kind of just wrote one giant file of switch statements with switch statements in them. Is that A+ software? Absolutely not. Does it work? Yes. In this particular case, when we're looking at this engineering process, we know a few things about this code base. What it does is unlikely to grow. No one's going to sort of fund new developments like they might in software. It's not going to grow to start doing a completely different purpose. It really has a little isolated purpose in life, one thing to do well. So the chances of it becoming hard to manage were pretty low. And all we ended up doing was representing all the state as a big enum, and like you can see here, just handling all the possible inputs. And if you didn't say exactly yes or no, then just tell them, sorry, I didn't understand. All of the sort of things we say back to the person as the bot indicate what they should say next. So it's a pretty easy experience knowing what to say next. And some chat platforms will even let you send back little buttons to click to sort of fill in what to say next. This code is really, really easy to reason about. We have some sort of storage mechanism, some sort of document store, keeping state for each individual conversation, as if you were a person remembering where you're up to with each conversation. And then we just have where you're currently up to and where you'd like to be. It really is quite easy to maintain. And we obviously have to deploy that. So at Polymathian, we deploy hundreds of Docker containers across AWS using ECS for sort of the UQCS half of the audience. That worked really, really well here. We wanted something we can kind of forget about. Amazon offers a serverless container solution called Fargate. They offer a serverless database called DynamoDB, and we can deploy this automatically on that. It's self-healing. It costs about $3 a month to run, and it kind of just sits there, not doing much. And then on the left, you can see the different sort of actors that apply to it. And the last one is the fun that I sort of covered on. The good thing about a chatbot versus a form is that it can have a bit of a personality. So we named the chatbot Chef Friday. He's a beloved part of the company. I think he's the favorite employee. Just got a cute picture for him, and he says some fun phrases. We tried to sort of make him a bit interesting. So sort of did all that. It took a couple of hours to develop it and a couple more hours to test and deploy, and it really wasn't a huge investment, but did it work? Yes and no. One thing I mentioned earlier about chatbots is that they're very hard to debug. One of the things we didn't really understand going into this was the difficulty of trying to debug something that is on someone else's computer that you can't reproduce. It's pretty hard unless you've got all the infrastructure to do all the testing, which we didn't want to do for something small like this. It can be really hard to try and reproduce problems. To this day, we have problems where sometimes he'll just say, I didn't understand. And then you'll tell him the exact same phrase, you'll just copy paste it, and he'll understand. So it's a little hard to maintain in that regard, but it really seems to be far and few between. He also just seems to focus on a couple of people he doesn't like. Everyone else doesn't have those problems. So after a couple of days of sort of patching him out, he ended up sort of being a beloved success. So that was 2 years ago. I know I'm talking about this as if it was recently, but he actually was deployed in July 2 years ago. We just had his second birthday. So that was kind of cute. There was a little party. And in that time, he has, sort of coming back to that process engineering, he has delivered on what we set out to do. So he's saved hundreds of work hours, he's reduced all the human error, and in that time, our employee count that he's dealing with, which we didn't really plan to scale for, has more than doubled, and not a single person has had to be trained on it, and we haven't had to make any changes to him to make him work. So it's been a really, really good experience. You can kind of see on the right-hand side what that experience is like. So every week now, he's organising lunch for maybe 40 people across 3 restaurants, and that time cost is minimal. There's a few things that still take time I'll talk about in a minute, but he kind of works, which is great. So what could we do? What have we learned from this process? So we tried to take something that had been developed ad hoc and it changed ad hoc and it eventually sort of failed because of that, and tried to really over-engineer it to the point where it was a bit of a meme inside the business. And it's not too bad. We did try to go all in on the chat thing. So this is the admin UI. You can see it's just chat. So that's kind of something that could be improved. We really could benefit from understanding at the time that chat is not the be-all and end-all. You can have these bots that have sort of multiple interfaces. So it's not good as an admin panel, we've learned. And you can see the same thing here, which is that having him spit out a markdown table of hundreds of burrito orders is a little hard to understand, particularly when there's no structure to the input. So one of the downsides of the chatbot is that the people on the other end are people. There's no drop-downs, there's no pickers, it's free form what the people put in, and you can kind of see that people will order the exact same food in completely different ways. The last thing we probably want to expand on in the future is automating it completely, right? Like, this is kind of fun and cool, but at the end of the day, all of this data goes back to one person who has to sit there, read out the big set of text, and then enter it into different ordering apps or call up restaurants. We do have a partnership with Delivery for Business, who are generally pretty great to us. We would love to see an API from them, which I think would complete this, where he could offer you the menu and then have you sort of put it back in chat and automate that part. Unfortunately, they're not very keen on that. Turns out programmatically automating things that cause things to happen in the real world is quite dangerous. And then they don't seem to be a big fan of allowing us to programmatically make people cook food. So we can dream though. So this is obviously a fun example, right? It's not too serious. It doesn't require any domain knowledge about the industries we work within. Everyone sort of knows what food is. Hopefully everyone's ordered delivery before. But it's something fun that we took the skills we had within the company and applied it to something in and of itself. We can sort of dog food our skills inside the company. Outside making chatbots, we do actually make real products. So we apply these sort of same fundamentals of analyzing processes that already exist, looking for the constraints, looking for those bottlenecks, and modeling that into mathematics. So at Polymathian, we use operations research, we use simulation, and we use sort of statistical, maybe stochastic modeling to take processes like this, but substantially bigger, potentially in multi-billion-dollar scenarios, and we apply them in much the same way. A lot of them start as going out, seeing the process happen, and then writing a Word document with a whole bunch of equations and notes in it. It really does start the same way, though the scale is obviously quite different by the time it's delivered. And then we build software around that, much the same as the chatbot, where it was built as a process that was then implemented as a chatbot in code. We sort of take these mathematics and we wrap that up in software, wrap that up in sort of Python, C++, use libraries such as Gurobi, some of the mathematics people might be familiar with. and we use that to sort of deliver solutions to our customers. So even if the toy problem in this case was tiny and kind of silly, the fundamentals are the same. So what do those problems look like, the serious ones? The classic one is like, how do you schedule an airline? If you've ever really thought about air travel and how does that actually work? How do you have thousands, tens of thousands of planes across thousands of airports, all arriving, coming and going and landing, and scheduled, priced, and all of these people moving around continuously, 24 hours a day around the world? It's unbelievably complicated, and if you think about it, it's kind of a miracle that we've gotten to the point that that even works. How do you not just rock up to an airport and they say there's no room, fly back to where you came from? And the answer is maths, and the answer is software, and it's this kind of software, it's operations research. And then beyond that, how do you not just make sure that the planes are going somewhere and that they will land and that that process works, but how do you do that while also making a profit? How do you not just fly randomly against hundreds of other airlines? Or how do you minimize costs so that you're not flying empty planes while still meeting all of your demands? It's the kind of stuff that we work on. We do a lot of mining, inevitably. Being Australia, mining is a very large industry here. You've got some sort of ore body, something very valuable. It's 2 kilometers underground. There's obviously a mining engineering side to that, where there's a physical way to do that. But you can model that entire extraction method and the entire 50 years, everything you're going to do as a series of constraints and mathematical equations. And then you can run that through very large cloud computers and plan out decades in advance exactly every step you're going to make so that you do it in an efficient way. You may want to maximize net present value. You may want to get the really good stuff out as soon as possible to make as much money as soon as possible, instead of just digging a big hole and seeing what happens. You may want to do the exact opposite. You may want to spread it out over 100 years so that your company has a stable, slow income, or the economy or the town that you're working within will have a guaranteed stable source of revenue for the next 100 years. And then a really fun one, I think, is sports. So we used to do Basketball Queensland, for example, or the fixture scheduling. Somewhat ironically, the local sports clubs don't have sort of money to pay for mining level software. So it's work we do for free. But it's also probably the hardest one we've ever solved. Maybe it was at the time, maybe things have gotten better since, but turns out fixture scheduling and having every team play every other team a fixed number of times with a fixed number of away and home games is actually quite hard to model, and one of the more interesting things that we've done. And how do you just find any solution? In that case, there is no profit to be made, there's nothing sort of mathematical to aim for. You just want anything. It's like solving a Sudoku, basically. You just have to make it fit. So, probably going to run a bit under time here, which will leave time for questions. A bit about us generally. We're founded in Brisbane, been here for 9 years, I think 10 years next year, which will be very exciting. We've got about 45 staff, the vast majority of which I'd say we've probably got about 50 staff, of which 45 are software engineers. They are people who didn't necessarily study software engineering, might have done mechanical, mechatronics, but then gotten into software. That's definitely one of the best things about software, is that it's something you can do with very little upfront investment. You don't need to buy much in the way of equipment. If you've got a gaming PC, you could probably run half the mathematics that we do. The other people that we sort of work with are the mathematicians, the consultants. There is a lot of sort of uniquely pure mathematics that goes into operations research. And importantly, that pure mathematics can also be heavily applied. So there's a lot on the research side from Garobi and companies like that who deal with the more pure things, and then what we do is apply that to the real world. And that's obviously also through the consultants. And we solve a lot of problems like this. We have over 60 software deployments, and a lot of those tools are sort of world first and industry leading tools even to this day. I believe that we schedule almost the entirety of the bulk trains on the east coast of Australia at this point, and obviously are in a lot of sort of mines and maritime around the world. It's a pretty cool place to work. Here's some pictures. That's us going skiing. We're actually going skiing in 2 days, so I'm looking forward to that. It's my weekend. And then on the right-hand side is sort of conferences and things like that, professional development. For the tech people in the audience, there's some logos that I slapped together. So C++, with the mathematics we do, with the kind of scale we work at in the different dimensions that we need to sort of generate these matrices, C++, the performance of that is incredibly valuable. But for all sorts of statistical analysis. If anyone's tried to sort of rotate a matrix in C++, it's probably not much fun. You'd want to reach for something like pandas for data frames and C-Clarkme for working with databases. We present our products as web applications. They're not usually chatbots. Most of the big mining companies aren't going to buy a chatbot that runs their entire business. Maybe one day. We can put a cute hat on him as well, maybe a little hard hat. But the kind of technologies used there, TypeScript, React, absolutely standard kind of things you'd see there. And then Amazon Web Services. So the absolute sort of leaps in what we've been able to do, not just us as a company, but the sort of applied mathematics industry has in no small part been sort of pushed through a new golden age thanks to the advent of the cloud. If you go back 20 years, there was absolutely no way that we could do the kind of things we do today in giving customers the ability to push a button and spin up a machine with hundreds of CPU cores for an hour and then turn it off and stop paying for it. It just wasn't something that was possible back then at the kind of scale we operate at today. So that's absolutely been a huge leap forward for the applied mathematics industry. We are always looking for bright staff. That's sort of, the reason to come out today is we're always looking for casuals, full-timers, particularly if you have an experience in Python, an interest in Python. There's job ads on the website for junior positions. We also have the careers email. So you can send us an email with any questions about anything about what we do. That's about it. Apologies, I seem to run for much shorter than intended, but I'm happy to take any questions about Chef Friday or process engineering. Just don't ask me maths questions. Yeah.
I was wondering, do you guys do a lot of machine learning in your work?
So we have done machine learning in the past. It's a really good question because it's one we get a lot from industries. Machine learning has been and sort of continues to be speculation about whether it is a fad, is it sort of going to make it into the broader world. The difficulty we have with machine learning when sort of talking to customers is usually if you've got a multi-million, multi-billion-dollar process, no one is going to be happy with a solution that you kind of just put it in a black box and something comes out and you kind of just have to trust that it's the best. You can't audit it, you can't explain it. For smaller problems, we have done that in the past, particularly where there's a degree of uncertainty in the data coming in. So anything where we're sort of planning for the future and no one really knows what's going to happen, so the data's bad to start with. But for what we do in terms of trying to optimize decisions, trying to make more money, often the margins there, if you're talking about a $100 million system, if you're off by 1%, that's $1 million. So even if you can get close, the exact mathematics and that sort of real mathematics of operations research allows you to get even closer, which can be a huge amount of money in some situations. And yeah, like I said, businesses are usually happier to go for something that they can understand, which can often be a hard thing even with this to sell, because a lot of people who are in decision-making positions aren't mathematicians, unfortunately, or aren't engineers, as much as we'd love them all to be. Cool.
How many business meetings do you have making decisions about the chef?
About the chef. So the whole point of the Chef Friday was to make sure it was time efficient. So there was sort of a joke there about what if we spend 200, the classic engineering meme, particularly for programmers, which is, I spent 200 hours finally automating something that takes me a minute a week, definitely worth it. One of the goals of this was basically to hand it off to a single person to follow this process through, basically report on it, and then just implement it. Because otherwise the time cost of going through the entire process would never pay off the time we'd save. But there have been sort of meetings since then about potential enhancements and new features and things like that. Turns out everyone wants to sort of change him in some way, but he's his own man and we don't want to sort of mess with him too much. Yep.
How much do the mathematicians interact with actually writing the software itself in the process?
Cool. So in terms of the sort of mathematicians, so we have, at the sort of highest level, we have the directors of the company, one of which has a sort of PhD in mathematics and does this. And then we have other people within the company with sort of those high-level qualifications. The answer is extremely highly. There is no one in the company out of 50 who is absolutely just pure mathematics, who just ships out a Word document of equations and touches no code. The difficulty of finding a programmer that understands mathematics enough to read your big sheet of equations, but not enough that they could just do it themselves, that person doesn't exist. You kind of need to be able to both formulate the entire problem and implement it yourself. That knowledge gap is just way too big. So every mathematician we have is also a programmer. And it's something we always repeat. A question we often get when we go to mathematics events is sort of, obviously the mathematics industry is sort of a substantially smaller, tighter knit one where everyone tends to know each other within Brisbane. And it's how do I stand out? How do I sort of get people to know who I am, and how do I find work? And often the thing we will always say is like learn to code in any capacity, usually Python, but NumPy, pandas, things like that. Allow you to take the mathematics you understand and apply them to real world problems. As fun as like pure mathematics usually can be to sort of do that kind of thing, a lot of where the money is and a lot of where the jobs are is in applying that to businesses. Because at the end of the day, you need to be able to communicate those decisions you're making. Even if you have the best decision making in the world and you have some amazing formula or some amazing algorithm that solves everything, if you can't communicate that to someone to actually implement it, they're not going to care. And we find that all the time, where we can send out a report and say, look at all this data and look, we've made everything better. But unless there's charts, unless there's some way that sort of someone at a management position can distill that down and actually understand it, it's effectively might as well just be gibberish. So, yeah.
I was wondering what types of mathematics or operations and research, like particular types of things we might recognise, you might use for different sort of sub-problems, because presumably you wouldn't just say to a client, here's the mega equation that models your entire business and everything you need to do. So
Absolutely.
I'm wondering what type of things relate to what sort of areas, like optimising schedules versus other problems that might be typical.
Yep. So within the broad technologies that we have, sort of the operations research, the simulation, the statistic analysis, the big differentiator that we find between, just keep in mind this isn't my specialty, I'm more on the tech side. The big differentiator we find is that statistical analysis is great when you sort of already have a problem and you need to understand whether there is something there that needs to be fixed, whether that's sort of that process analysis. You never want to just leap in and say, like you said, here's the big mega engine, let's find out some way to glue it into your company. There may not be a problem, they may not understand what the problem is, and that sort of statistical analysis is valuable. Then when it comes down to the operations research versus the simulation, simulation is very, very valuable when there's some level of randomness involved. So it's essentially impossible for us to perfectly and accurately mathematically model something that is random and give consistent, reproducible answers. So the simulation allows us to inject that randomness, run something hundreds, thousands of times, and then see what actually happens when it all goes wrong, if there's some slim chance of a failure, what if the weather's bad, that kind of thing. And Kev here, who's brought with me for questions afterwards, he works on our simulation team and knows a lot about that. Within the operations research, you'd actually be surprised how reapplicable some of the models are. Sort of the company's matured to the point where we have sort of 5 or 6 generic models. And what we do and what we specialize in is taking that real world, that sort of less perfect, and abstracting that and applying that down to the models and the engines we already have. So our engines are often quite generic. One of our biggest engines is called the Network Flow Optimizer, and it, in a sort of abstract way, models and optimizes the flow, whatever that might be, of something through a network that has a series of nodes, like a graph, over time. And that is surprisingly generic. That is something that can be used to model ore processing. So it comes out of the ground, you have decisions to stockpile it or to process it into something else. Do you ship it overseas for processing, that kind of thing. But then that also applies to our wheat customers. So we have a grain customer, which turns out grain and coal are very similar, even though at the surface level they may not appear to be, where you have that same idea of some sort of process that something could go through. And even within mining, you could take that away from the entire supply chain and just say, I'm running a factory that does chemical processing of materials. I have all these different machines that have different maintenance potentials and blackout windows. How do I move things through and use my machines in an efficient way so that something, the most of something, comes out at the other end? So the skill and the real thing that makes the company successful is that ability to take the sort of the gritty real